Now, ladies and gentlemen, this is part of your SAT review. This is what we're going to be doing a lot of as we're moving towards your real SAT. Depends on when the snow actually hits and how much. I'm hoping. I got to finish watching Daredevil. I'm on like 10 or 11. All right, now. Oh yeah, they've already made decisions based off of stuff like that. But don't worry about that. That's all school-driven stuff. We can change plans. We can do all sorts of stuff. All right. Yeah, we already changed it once, and if we change it again, we change it again. Or if they get rid of it and not even have to do it, we don't do it. It's not a big deal. I mean, at this point in our circle for you guys, for you juniors, and I think most everyone's a junior in here, we're just kind of rolling with it. If you're taking the practice SAT tomorrow, you know what? Do your best. See where you stand. I'm going to ask you tomorrow what you knew and what you didn't know, so we can kind of base what we're going forward with to the SAT. But the thing is, we don't know that yet. All right. So the first thing that I wanted to show you, when you have a function, and these videos I'm going to put up on the web eventually a little bit, and they're not necessarily, I don't need that. They're not necessarily going to be of the actual problems that are in these packets because, for various reasons. But I want to show you a couple things. If you take a look at any single point here, this point is going to be listed in the coordinate plane like this, if we're talking about a function. Now, I know that you guys are used to seeing points that are in this form, x, y. But one thing that you have to do, and yes, you're going to see y equals a function of x a lot, but you're going to see a lot more the farther you go in math, f of x is equal to something, where this is the name of a function. Your y and your f of x are the same thing. Y is equal to f of x. This is just more specific because it has, it has a value of x. So if I wanted f of 2, I knew my x was equal to 2. If I wanted f of 5, I knew I want x equal to 5. Now, if you want to think of this, your x, we're going to call that our input. And our input is specifically of the domain. And I know for a fact, as soon as you started seeing your first function, that they started throwing words like domain and range. And you might not have understood it then. You might not have understood in Algebra 1. Geometry, you got a respite from it because we didn't talk too much about domains and ranges, which is neither here nor there. But the domain, if you think of it, and I want to try and make it as easy as possible for you, the x's we can legally use. Now, by legally, I mean mathematically legally. So sometimes, let me move this back just a wee bit. Sometimes when we're talking about domains, it's going to be x's we are told we can use. We might be told we can only use x's between 1 and 10. Or if we're dealing with time, we might be dealing with time equals 0 to time equals 20 because time equals -1 doesn't make any sense, does it? What's going on at -1? If we're launching a rocket, the rocket starts at 0 when it launches. So we go from 0 to the positive numbers. So sometimes we're told exactly what we can use. Sometimes we kick out x's that mess up the function. And this is when we like divide by 0, when we're taking the square root of a negative number, even though, oh, sorry about that. Thank you. Haven't we been able to take the square root of a negative number before? And we got I? Yeah, we can do that, but a lot of times when we're in the real numbers, the negative numbers, we don't really like to deal, the negative square roots, we don't like to deal with that. So if we're trying to find domains, we want domains where square roots are 0 or bigger. So we have a lot of choices when it comes to domains. Now, if we're talking about this part right here, well, let me go back right over here. These are the values of the functions. Which we can think of as answers. If I plugged in x equals 2, what's my answer? If I plugged in x equals 10, what's my answer? Well, the range, and this is what my range is, that's your answer. Now the cool thing is the graph represents all the answers, which we call value. We call them values. Values. So the value of the function when x is equal to 2. Because a function is supposed to represent some type of real life situation. Not all of them do. Some of them we just do them in the context of a math class, and so we have a crazy function that doesn't mean anything, but we can still get a value of that function. So whenever you're seeing the y values or the f of x values, those are our values. Those are our answers. Those are the only answers. Now, a lot of times your answers aren't every single y value. So lots of times your values, which are your answers / range, are not all real numbers. So you get to put on your Sherlock Holmes hat and figure out, all right, based on the graph, what are the answers? What are the answers that we possibly can get? And a lot of times when you're looking at the graph, I'm going to show you different ways that you can figure out what your domain and range is, just by looking at the graph. And that's what part of this packet is doing. This packet is trying to help you come up with these different answers. And I can't make videos of the packet, but I can use them for instructional purposes, and that's what we're going to do. But I wanted to make a video of this that kind of talks about, all right, when we're looking at specific points or all the points, your x values are your domains. And if you're ever asked what's the domain of the function, what you look for are the values that are going to make the function fail. We never look for all the good ones because there's a lot of good ones. We look for the bad ones. We look for the ones that we don't want in the domain. And then the range, it's helpful to look at what a graph is, because then you could just pick it right off the graph. But if you don't have a graph, then you got to do some work there. You got to figure out what's the smallest value, what's the largest value. Are your answers only between 1 and 10, or do they go from 1 to infinity? Or do they go from 1 to negative infinity? Sometimes they do that. So you have to play a little bit of detective in this. I'm going to show you, we're going to go over this together, some different ways of kind of fighting through this and working on those. So this is going to be up there, kind of like a quick this is a quick explanation. This is about the 9th time you've seen domain and range, I'm sure. But the biggest thing is, if you want to find the domain, find X values that won't work, and then kick them out. Look for stuff that's going to screw things up. Do we want stuff that's going to screw things up? Ever in your life, do you want things that are going to screw things up? No. We all want to have a nice, happy life that's as stress-free as possible. We don't want things that are going to screw things up. Is a snowstorm going to screw things up? Yeah, we don't really want a snowstorm. Now, granted, this audience is totally different. Normal people, normal adults who have to go to work and do all that stuff besides teachers, they don't want a lot of snow to fall because it's going to be a pain to get to work. Because a lot of times work doesn't close. Schools close. So we like snow days. But for the majority of the people out there, they don't like a lot of snowfall because it makes driving miserable. It really does. And if you've driven in snow, it's awful. It is the worst thing to do. You just haven't, honestly, last year and this year, you haven't driven in bad snow yet. You haven't yet. Freshman year was bad. This year was not too bad. So let me stop this recording and let's start talking about some of